starting the project. So we today we had a long weekend here in Queensland, and so I'm just back to the office right now. Actually, I was missing a cable. Hopefully this will work. I think YouTube tells me excellent connection. I see sound going up and down. I think things are okay. Yep. So, all right. So let's just get started directly. We are working in the sardine project, and actually I still have everything here. Let me just switch over to my screen. So here's the screen. So we still have everything we had last time. Let's just check. And everything ran in the meanwhile. So we were running to produce these plots, which I'm going to show you in a second, just as a recap of what we've been up to. Plot simulation results. So this is what we did, and then we plotted this. We plotted these graphs here, right? So we had done this for one species before, and now we did it for a subset of them. So here you can see on the bottom right, as we increase the number of mutations, this is by simulation, we start to change we start to get artifacts. So we introduce some sequences, and we disrupt sequences, and so we sequence compared to the initial starting point. We have some errors, some new sequences, and some old sequences go missing. So here's sometimes some of these are interesting, but you can see that they all kind of look the same. Not sure if it means much that the differences between them. So one of the things that we are doing here, which is not very sophisticated, is we're really just seeing, did any sequence change at all? We don't have any checks as to whether that change would be or not be, relevant. So maybe some of these changes are not relevant. So I thought I would start actually by checking some of that today. So I'm gonna and then I was thinking of so we were doing this at the sequence level, and then I realized this is actually a little bit less. Well, it's interesting, but it would also be interesting to see if by any chance we could do it just do the same thing, but looking at the eggnog OGs. So do we lose or gain eggnog OGs? Because the loss of OGs is what then tools like CheckM or CheckM2 actually pick up on. So CheckM2 works based on the gene sets. It does not work based on the sequences themselves directly, just on the gene sets. And so what matters is whether we are gaining or losing eggnog OGs, right? So this is the output. Probably want to do something a little bit similar. Okay. I don't know why today I'm doing this on the expanded. And had we done let me see, got complete OGs. Right, this functions here. So eventually we will want to do check that. I really just want to check this really quickly. What did I call it? Was this what I called it? Exponent? Okay, was it? Okay, right, so this is all right, this is much okay, this is much okay, interesting. Okay, so okay, this is somewhat interesting, I guess. So what this means is that we have, so the OGs actually barely change. So even yeah, so you can see here number of mutations in the thousands, and we're talking single digits. Single digits number of mutations. Only when it gets into, alright, interesting. I'm gonna keep this as a, that's right. Okay, alright, let's start with this. Okay, so this is just a refactor, meaning, you know, we're not changing what the code does, we're really just changing the organization. But so sometimes in these things I like to, you know, first do the refactor commit, which does effectively nothing. All right, we just moved one function from one file to another file. Everything should work exactly the same, but it sets us up for the next step. Yeah, so it sets us up for the next step. Okay, so right now we're just gonna merging everything here. Okay, something like this. Not a super big fan of this code, but you know, why not? Not a super big fan, but it will work. I just want to run it, just see if it runs, and then if it does, we will plot. So we're just gonna okay, we're just gonna see if this works. I'm not a super big fan of this code, but right now it does a job. I mean, as this is running, I've talked about and I've written about. So let me just find it here. I've written about this idea that we have that there's code that we produce for different reasons, and so we're still at this level. This is a one-off analysis. Maybe slightly a little bit cleaner than the typical one-off analysis code, because I am sort of going to commit it. And if/when we move towards doing a paper on these results, we would potentially move towards this level where we're talking about extended, so we'll call it extended methods code, which is code that we put out in support of a publication, and most of it is for a very small fraction of the reader. So when we put out, say, for example, the MP Sphere paper, that we expect that most of the readers of that paper will not going to look at the code that generates those plots and did those analysis, but the fact is, when we write the method sections, there's a lot of ambiguities, and so putting out the code sort of disambiguates those ambiguities, if you pardon the awkward phrasing. And then finally, level 3 is when we have a tool. So for example, thinking of SemiBin, where our main purpose is that people use the tool. So if you want to use SemiBin to get your mags, we want you to do that even if you don't read the paper. So in some ways it's the opposite. We actually expect that some of the readers, some of the users will not read the manuscript, or if they read it, they will read it superficially. They might not be wanting to go into the details of the contrastive learning loss function and the architecture of the neural network. That's absolutely fine. All the information is obviously there, but if we do want people who are, all they care about is can they get the best mags possible out of their data to be able to use them. So all right, so this was a little bit of a digression also because this is running here, but this is something that's been important in my structuring of thinking about these issues, but I've also put it out there. Just quickly, all right, let's see. Let me just quickly check that something is running. Yeah, something is running. It takes, I don't know why, sometimes some of these take a little bit longer. Just see. Okay, I am going to preemptively I'm going to preemptively run that, and I wanted to check. So okay. So actually, I think I ran this before, but I ran it on a different. I don't know why it's if I do this. It says it has not run, but in fact it has run. And I think basically I ran it on a different computer. So we have this here. Yep. So 74 million, right? And actually, even this, the first column doesn't really matter. What we want is the next two columns, eggnog OG1 and AA size. And how big is this file? Yeah, this is what we want. Okay, so we have this length by KO script. Just checking here. And this length by KO script, which we used in the past to analyze but right now we want, let's see if we can adapt it. Okay, let's see if we can load it first of all. While that is loading. Okay, that was pretty fast. No. So what do we want? We want to group by. What's the name of eggnog? Actually, before we do that, yeah. So I just want to have you know, build a little bit of intuition. So sorry about this. OGS counts. Building a little bit of intuition of what's going on. Let's check. Why is this so slow? Why does this take so long? There it is. All right, so 200,000. So what if 200,000 of which, okay. Mean images per this should be per OG, but okay. This is okay. All right, something's wrong here because we. Yeah, I know what's wrong is that I did the filtering before. Okay. All right, we can do this. This is absolutely terrible, but it will work. Again, I am not not a big fan of this code. Yes, this is sorry. Yeah, this is kind of terrible code, but basically because we're just copying and pasting. I think we played around with trying to get this into, to do this with a group by, right? Because this is kind of a group by, but no. But yeah, well, it's probably figure this out, but let's ignore it. Okay. And this should work very well. Again, nothing. Okay, okay, and here. Let me just check here. Has this something running? Yeah, it's running. It's been running. Okay. Yeah. Okay, right, so the problem is I think we need these expanded outputs, so let's just get them somewhere. So let's make expanded here. Let's make expanded be a dictionary, and then we just save all of them. And then we can load them back. And I frankly did not expect this to be. I'm just gonna. It seems that for some reason. Okay, we need to restart here. Let's restart here. Because now. I think if we make a push today, we can get to a try off with horrible code, but something that will give us some idea whether it works or not. Route. Okay, so right, I'm just rerunning what I ran before. There it is. Potentially this should be done once and saved as part of this other get complete OGs script, but this for now is fine. Oh, actually, I did not mean to do that. What did I change? Oh. Yes, okay. Right. Okay, so by the way, this is the thing that was running before. All right, and now it's just running for all of them. Okay, this is perfect. This is what I wanted before. Yeah, and now just okay. All right, back to here. All right. All right, so now what I want is I want to get the I honestly don't know why this is so slow. Oh, there it is. I think some of them are very slow and some of them are not. Right. All right, maybe one thing we could do pretty quickly is there's too many columns here. What do we care about? We care about number query, eggnog. G original. These are actually the three columns that we care about, right? Oh, sorry. Yeah, I think everything can be done with these three columns. So why don't we very quickly okay, very good. Oh, yeah, this works. Yeah, now the simulation results plots were invalidated, but so right, so just so that everybody can see. So what I did here is, okay, instead of using the expanded with everything, let's select the columns. So this means that at one point Jug is going to load it, and then just select these three columns. But my hope is that by getting rid of the other 19 that do not matter, everything else becomes very fast, because a lot of this loading and unloading is just a hassle. So let's just do that. We could even potentially pre-process the original to just give us the number of mutations, because that's all we really care about. But for now, let me just test the code. Let's just do a bit of okay. Emapper. Okay. Does this work? Yep. Wait. Wait, we don't have. Oh. We don't have the. Right, yeah, but we don't have. Now we need. Get all gene positions. Okay, I'm gonna. Okay. Okay, so this gene positions is the same as the probability expanded variable, is that we need to save them all for the, we need to save them all. So not, okay. Positions, tag. Okay. Okay, right, so nope. Okay, right, my bad for not trusting. Okay. Right, this is what, right, this is it. Okay. Okay, this is it. Actually, I've decided I'm gonna do this. I'm gonna remove the older code, and then we'll just save it as a different file. Again, absolutely horrendous in terms of software design, but this is proof of concept code for now. We will eventually okay. Okay, wait a second. So now I need to add the mean All right. All right. This should actually work. Sorry about that. I did not mean to. Let's do this again. Yeah. Alright, now let's do it again. It's this one. Okay. Okay, this is a bit weird. It's frankly not at all what I expected. Right, yeah. Okay. Yeah, this is not what I expected at all. Oh, okay, this one, no, this one is fine. Sorry, this one is fine. This one is what you expect, right? A shift to the left. But this one is a surprising one. So this one, so z-scores of 60. This is, right, right, but here the average z-score is 5. This is some. There's very few. It's surprising. Okay, I want to wrap up here. I'm surprised by these results, to be honest. So there's a lot going on. We also need to there's a lot going on. All right, I'm actually surprised by these results. I did not expect, because this means this for this organism the average z-score is 7, which frankly seems quite high. It seems quite high. Okay, we're gonna have to wrap up now. So I'm gonna save this. Actually, right, so some of this is fine. Okay, I'm gonna put all the plots in a separate plots. Just do a lot of plots, a lot more plots than before. Okay, so alright, so let's do this. So I'm adding it to a different. So I'm just saving it as a different file. Let's see again. Again, let's first commit this one. This is just a refactor. This doesn't change anything, but it allows us to then use it later. Okay, this is actually very, very surprising. I'm gonna but the other idea would be to use not the maybe the GMGC is just a bad reference. Maybe a lot of the genes in the GMGC that we think are complete are actually truncated, even though it's a bit surprising how yeah, I'm sorry, I moved on. I don't know what's going on, but we will have to wrap up. Okay, this is have to wrap up. I will also just run. I will just also just maybe we are also choosing the wrong. Let's spend a little bit of time next week trying to figure this out. I'm just gonna push everything for now. So again, I'm pushing this everything on the, am I pointing in the right direction? No, it's that way. Everything's on GitHub, so please do follow along if you want. I will also be posting on the mailing list, so follow along there. I will also be at some point getting a little bit better with the recaps. I mean, we've had a bunch of holidays here in Queensland. Yesterday was a holiday. Last week we had some holidays. There was Easter, so everything was it's been a little bit topsy-turvy the last couple of months. Or not the last couple of months, the last month and a half. But especially because these are actually very interesting results in their own way, in that they're fairly surprising. But I do want to, I'll have a look. I'll run this also on the whole data set, on the whole simulation data set, and then I'll report that on the mailing list. So in the meanwhile, be well, and talk to you soon.